Dear viewers, in today's presentation, we will delve into the implementation of the OR logic function using a 4-to-1 multiplexer. Our main objective is to realize OR logical gates and its operations using 4-to-1 multiplexer. Block diagram of 4-to-1 multiplexer is shown here. Now, let's examine the truth table for the OR logic gate, accompanied by its symbol for your convenience, as depicted below. This logic gate features two input, designated as A and B. A solitary output, labeled as Y. Given its twin input nature, there exist four potential input combinations. Prior to implementing the OR logic using a 4-to-1 multiplexer, it's essential to provide a comprehensive explanation of the block diagram. Within this diagram, we observe two select lines, S1 and S0. Additionally, we have designated the enable input as active high, necessitating its connection to a logic high level, typically represented as positive 5 volts DC. Now, let's revisit the truth table of the OR gate once more for clarity. We have two inputs for a OR gate. So, we will assign S0 as A and S1 as B. When A equals B equals 0, a logic 0 is required at the output as evident from the truth table of the OR gate. We also know that when the select lines, A equals B equals 0, the input I0 gets selected at the output. So, a logic 0 at I0 will direct it to the output as per the OR truth table. If we set A to 1 and B to 0, according to the OR gate's truth table, we necessitate a logic 1 at the output. As per our understanding that when the select lines A equals 1 and B equals 0, it activates the input I1 at the output. Therefore, when input I1 carries a logic 1, it aligns with the OR truth table and directs it to the output. When A equals 0 and B equals 1, a logic 1 is required at the output as evident from the truth table of the OR gate. We also know that when the select lines A equals 1 and B equals 0, the input I2 gets selected at the output. So, a logic 1 at I2 will direct it to the output as per the OR truth table. When A equals 1 and B matches with a 1, once more, we seek a logic 1 at the output, as clearly indicated by the OR gate's truth table. It's worth noting that when the select lines A equals 1 and B equals 1, this synchrony activates input I3 at the output. Consequently, a logic 1 at I3 aligns perfectly with the OR truth table and channels it to the output. Having previously explored the implementation of the NOT logic using the IC 74153 in our earlier video, we shall now bypass the functional details of the IC 74153 and instead focus on applying it to implement the OR logic. The figure provided here illustrates both the internal block diagram and the functional table of the IC 74153. Now let's finish the connections and realize the OR logic using the IC 74153. Since we need only one multiplexer, we will consider the upper mux having inputs 1I0, 1I1, 1I2, 1I3. Connect the 16th pin to the positive 5 volts of DC regulated power supply as illustrated. Now connect the 8th pin to the ground terminal of the same power supply. To enable the multiplexer, connect the first pin to the ground terminal. This pin, denoted as G1, serves as the strobe input for the upper multiplexer, ensuring that the multiplexer is now ready to operate. Establish a connection to pin number 6, representing input 1I0, by grounding it to a logic low of 0 volts. Simultaneously, link pin numbers 5, 4, and 3 to a high logic level, precisely plus 5 volts DC supply. Consider the select lines, specifically designating pin number 2 as B and pin number 14 as A, as the inputs for the OR gate we intend to create using this multiplexer. Please make note of the output observed at pin number 7. When both inputs A and B are set to logic 0, the input line 1I0 becomes the chosen path to the output. In this configuration, where pin number 6 is connected to logic low, the output at pin number 7 will also hold a logic low state, aligning with the outcome observed in the initial OR logic combination. When A is set to 1 and B to 0, the input at pin number 5 directs its path to the output at pin number 7. Given that input 1I1, linked to pin number 5, carries a logic high, this results in the output at pin number 7 being high, consistent with the expectations set by the OR logic truth table. Now, if we consider that input A is at logic low and B is at logic high, this causes 1I2, linked to pin number 4, to be chosen as the output. In this scenario, where the logic level at pin number 4 is high, the same high logic level will be present at the output of the multiplexer, in perfect alignment with the OR logic truth table. In the context of our present consideration, let us posit that the input A is set to logic high, and concurrently, B is also configured to logic high. Consequently, the input 1I3, which is affiliated with pin number 3, is designated as the output source. Under these conditions, where the logic level at pin number 3 is ascertained to be high, it follows that the same high logic level will manifest at the output of the multiplexer, thereby impeccably conforming to the OR logic truth table. In today's lecture, we explored the implementation of the OR logic using a 4-to-1 multiplexer, and we elucidated this process using a block diagram. Subsequently, we delved into the internal diagram of the IC 74153. We also provided a comprehensive explanation of the functional table for the IC 74153. Ultimately, we successfully implemented the OR logic gate using the dual 4-to-1 multiplexer, specifically the 74153 IC. A heartfelt thank you to our attentive audience for joining us in this educational abundance. Your time and interest, we deeply endorse, in the world of tech, where knowledge takes its course. To keep this journey alive and bright, we kindly ask, with all our might, please share and subscribe, take flight, with iNet Tech Talk, let's reach new height. Your support means the world, we truly believe, together we learn, and together we achieve. So, spread the word, and let's all conceive a future where learning, we continually receive. Thank you again.